I just had a few examples left from yesterday, so if you could just get your notes out. We didn't do one with the number in front, so if you were struggling on that on your homework, and we only graphed cotangent, we didn't graph anything else, so I thought we could do this one really quick, and then a couple to help you with the end of the homework, and then we'll see where we are on time, probably out of time. But I brought 36 cans of food today. I went to Aldi's yesterday. Well, I learned I have a box down there, so I decided I need to contribute and try to keep myself from kissing a pig. So I want to put it in Miss Nichols' box because I think it would be hilarious. But Parker wants to put it in Mr. Love's box, and Mr. Love is heartbroken that Parker wants to put it in his box. But Parker, every time we walk in the hallway, he reads or tries to read the teacher's name, and he can read Mr. Love's name because he knows the word love. So he thinks it's hilarious, like he thinks his name is hilarious. And so he's like, we're putting in Mr. Love's. And this morning Mr. Love came down and I said, Mr. Love, I bought 36 cans of food. I said, I want to put it in Miss Nichols, but Parker wants to put it in yours. And he's like, what? Like, so he's really mad. But I told Parker we had to split it, so. He said he's going to the store. Like, you're going to get lots of canned food from teachers because we're all like going to the store and trying to like keep. Yeah, like we're trying to put it in others, so we'll see. I told Parker I'd wait till the end of the day so he could help me. But, I went to Aldi yesterday. 49 cents for 49 cents for green beans, corn, other vegetables, and pork and beans. I was gonna just get all vegetables, but then I got 12 pork and beans too because they're only 49 cents. So $17 I spent, 17 and some change for 36 cans of food. So. When you're graphing these, tangent and cotangent, you have to find your asymptotes. So this is the one thing you have to know. Cotangent has sign in the bottom, so the asymptotes you set equal to 0 and you set equal to pi. If it's tangent, you set whatever's here equal to pi halves and negative pi halves. You gotta find your asymptotes. If you don't find your asymptotes, unless something was added up here, which we're not going to graph any like that, but I could ask you to find asymptotes of something like that. So all the ones we're going to graph it should be at 0. This is not from your homework. This is my notes.
I don't understand the asymptotes. Like, where do you get the 0 and the 9?
Because this is what we talked about yesterday. Cotangent of x is the same as cosine of x over sine of x. Yes? You can't have 0 in the bottom of a fraction. Where does sine equal 0? Sine equals 0 at 0 and at pi and at 2 pi and at 3 pi and at 4 pi and every multiple of pi. We just want to find 2 in a row. So pick 2 that are in a row normally, set whatever's here equal to that, and solve it, and you will always get 2 consecutive asymptotes. Same thing with tangent. Tangent has cosine in the bottom. Cosine has 2 asymptotes at negative pi halves and pi halves, which is why that's what we set that equal to. Cora. You're good? Okay. So if I solve this, I get x equals 0 and x equals pi fourths. And pretty much, unless there's some crazy shift going on, cotangent's asymptotes are at 0 and whatever the next one is. So that's how, like on the matching ones, I always match up which one's cosine or cotangent to begin with, because the asymptote's at 0. So if I was going to graph this, notice I made a very little graph over here. At pi fourths, I would have an asymptote at 0. I would have an asymptote at pi fourths. What's important for you to do is you have to graph at least 2 periods. So you've got to be able to tell me where would the next asymptote be. How far is it from 0 to pi fourths? It's only pi fourths, right? Right, we're not going negative pi fourths to pi fourths. We're just going from 0 to pi fourths. So we're just going to go another pi fourths, which would be 2 pi fourths, or pi halves. So I like cotangent better because I can just add whatever the distance is. If you can find your asymptotes, you've got a really good shot of getting a right graph here. Oh man, that's a terrible line. I don't know what happened to my straight lines I was making yesterday. But. Where's Philip? Did you kill his dog?
I
thought he killed him. I thought he. But the dog was.
What happens in between your asymptotes? What should you get halfway in between? 0. And then this is where if you forget which way it goes, actually plug in one number. And if you plug in one number and you know how the shape is that S shape, you should be good to go. This would be, oh my goodness, this would be pi 8ths, right? So what would be halfway in between 0 and pi 8ths? Pi 16ths. And if you plug pi 16ths in there, you should get pi 4ths every time. And that's how this works. Because 4 times pi 16ths is pi 4ths. The cotangent is 1. But then that 3 in the front means that we're actually going to go up here to 3. So that should be up here at 3. This one should be down here at -3.
So basically, it's just, okay.
Stretching it. I agree. If you can find your asymptotes, it's pretty easy. Sine and cosine aren't that bad either, because it's just a pattern.
It's just, and we have to think, you actually have to like solve it out with this, just like, oh.
Half and half.
Be like, whatever direction it is, if it's up or
Yeah.
that's what you have to go by.
Yeah.
I feel like it's too easy.
Don't complain, it's too easy.
That is a little concerning, but sometimes you're like, ooh, I messed
Well, what's hard is when we have a test, you're going to have sine, cosine, tangent, cotangent, secant, cosecant all in one test. And then you got to keep all the rules straight. That's where it gets difficult, right? It's easy when I break it up, but just sine and cosine this day, just tangent and cotangent this day. So on the little homework quiz that we took last week, and I asked people like how they were feeling about stuff, 4-4 day 1 came up most often as issues. And that's kind of what the rest of the homework was last night that I told you to stop on, of solving these equations. And they're kind of taking baby steps here of maybe not solving on the whole circle yet. So let's look at the last stuff here, and then maybe you'll have time to start some homework if you didn't get it all grabbed. So the last part of your homework says solve over the given interval, and I think your homework actually breaks it up into 2 parts. Yeah, like part of your homework says you should be able to do this without a calculator, Dave Crosby, using reference triangles or unit circle.
I did the first 2.
But then the next part says use a calculator. And when we take the test for this part of chapter 4, which who knows when that will be, we will have 2 parts of the test again. We'll have a calculator part and a no calculator part. And the part like this, like number 5 here, would definitely show up on a no calculator part, because I still expect that you can give me answers from the unit circle or from your reference triangles here. And so this says solve over the given interval. So they're telling you you're only solving from 0 to pi. It's also telling you your answer should be in radians because you're going from 0 to pi. And I want to know what angle has a tangent of the square root of 3. So you have to think from 0 to pi, that would be here and here, yes? Where would tangent equal the square root of 3? First of all, from 0 to pi, we can eliminate half of the choices here, right? What quadrant is tangent positive? Is it positive in both of these? Which means you better not give me an answer over here, because tangent cannot equal positive square root of 3 over here, yes? Yes. So now I'm over here, and if I'm in the unit circle, I only have 3 options. I'm either going to be at pi 6, pi 4ths, or pi 3rds, or I guess I could be pi halves, but it's not the square root of 3. Right? Could I eliminate one of those 3 options? Pi 4ths does not have a square root of 3 in it, right? It's square root of 2 over 2, square root of 2 over 2. Which means if you just have any idea what you're doing in this problem, you're down to a 50-50 guess right now without doing any work by just knowing tangent is positive in quadrant 1, and the only options that have a square root of 3 in it are pi 6 or pi 3rds. You guys are crazy unit circle people. I would draw a triangle here, but I'm trying to stop myself. Square root of 3 over 2, 1/2. This one's 1/2 square root of 3 over 2. Right? And what's the ratio for tangent? Sine over cosine, y over x, right? So y over x, square root of 3 over 1. or y over x. You with me on that? Remember Philip discovered this lovely little trick. I hope you've been using it because it taught me a cute little trick.
Oh, it would be the ones it would be pi 6 because then like no, it'd be pi 6.
If you do this one, you get 1 over the square root of 3. But if you do this one, you get square root of 3 over 1, right? You don't have to do the complex fraction because the 2's are always going to cancel out, right? If you do the tangent of pi thirds, if you work it out, you get square root of 3 over 2 over 1/2. And you flip that up every time the 2's are going to cancel, which is why Philip said, right, y over x. Which means I can say theta equals pi thirds.
And I know you said you're trying to stop yourself from drawing a triangle. That would have been really especially
I
since
always do triangles, yeah. Especially when I'm doing tangent, I always do a triangle, and like this is what I do when I know I'm between these two. I say, that's 1, 2, square root of 3. Just kidding. Oh my gosh. Never mind, I quit.
I got it.
I always look at one, and if it doesn't work, then I know it's the other one, is what I was trying to say, but I couldn't even draw a triangle right, so fail on trying to show you triangle better. But I always draw a triangle.
In the circle 1, try.
But I like triangles. Take calculus next year. I'll be drawing triangles in August, and you'll be drawing unit circles, and I'll try to convince you otherwise if you don't use them. What about this one? Where does a cotangent equal 1.2? Is 1.2 in my unit circle? No, which means this is where you'd have to use your calculator, and this kind of goes back to what we did on 4.4 day 1, that worksheet that people said, I think I need some more help with 4.4 day 1 because it's a crazy mess. This is where you have to use your calculator, and if I'm going from 0 to 2 pi, is there going to be more than one answer? Because is cotangent positive 2 times? So if you're going all the way around the circle, you're going to always have to give me 2 answers. If it's in the unit circle, you just figure out where it is twice. If it's not in the unit circle, you have to use your calculator, and then you have to kind of use your brain. So if you don't have a calculator, I'll throw one at you. Can you use calculator? Know the difference between second hour and sixth hour. Not that I like to compare so much. But in sixth hour, I have to give out like 10 calculators. Not that that needs to be, but I'm always prepared in this class, and no one ever needs one. There's no cotangent button on my calculator, right? So if cotangent of theta equals 1.2, that's the same as saying tangent of theta equals 1 over 1.2. Yes? And if you want to make that a decimal, you can. I just always type it in my calculator just like that, 1 over 1.2. And if I'm solving for theta without doing, it's not in the unit circle, I have to use my calculator. What button do I use in my calculator? Inverse tangent. Oh my goodness. I can't wait for Mr. Puckett to come in here. It'll be so awesome. 1 over 1.2. I'll be trying to draw my triangle, and I'll get it wrong. I don't even care anymore. And your calculator will give you an answer. Should we be in degrees or radians on our calculator right now? It says 0 to 2 pi, so we should be in radian mode. I'm going to put an inverse tangent of 1 divided by 1.2, and it's going to tell me that the answer is, if I go to 2 decimal places, like 0.69. What quadrant is 0.69 radians going to be in? Quadrant 1. Does it make sense that tangent and cotangent are positive in quadrant 1? That's going to give me a quadrant 1 angle? Yeah. What other quadrant is tangent and cotangent positive in? Quadrant 3. And your calculator does not give you that answer. That's where you have to kind of draw a little picture and say, okay, it doesn't really matter where, but yes, or you just know already, because you guys are so smart, that to get from quadrant 1 to quadrant 3, you're just going to add pi. So for tangent and cotangent, it's always easy to get to the other quadrant. And you're just going to take 0.69 plus pi. It's not 0.69 pi, right? It's 0.69 plus pi,
Plus pi.
right? Like we're not multiplying by pi. And so I usually say, the directions usually say to round, and so I just say add pi, and I would get like 3.83. So you got to recognize that if we're going all the way around the circle, we're going to have two answers. A lot of the ones on the homework today are not going all the way around the circle. Like on number 5, it might just be one answer that you have to give. Okay? So that's what we did for 4D1. It's going to show up over the next few days thrown in with these graphs. And so that's why I wanted to spend one day on it before we started all this. And now we're just going to keep throwing it in, hoping that you feel better about it.
So are we just doing whatever's left we didn't get done? Or?
Yes, and so if you did all the homework yesterday, you have much less to do today. If you didn't do any of it, you have a lot more to do. Tomorrow we will do the rest of this, which is graphing secant and cosecant.
How do you think those graphs are? Okay.
If you know what sine and cosine look like, they're really easy because they're just the reciprocal of sine and cosine. And so, like, instead of having, like, up and down like this, it's just, like, flipped over parabolas. It's kind of weird. But they're not bad if you know sine and cosine. If you have no clue about sine and cosine, then it's a little crazy tomorrow. This is 4-5, still day 1. We just ended up spending 2 days on it, and 6th hour hasn't even started this, so who knows what they're going to Yeah. So yesterday I told you to do through 14, and you didn't have to do the rest. If you did all that, you only have to start with 31 and 34, and those are like what we just did, 31, 34, 35, 37, 40, and then I think 44 is a multiple choice. Oh no, it's